For question 1, I'll start with 1400 and successively divide it by prime numbers. 1400 divided by 2 gives me 700. Divided by 2, it's 350. Divided by 2 is 175. Divided by 5, 35. Divide by 5 again, 7. And finally, divide by 7, you get 1. So the required product is 2 to the power of 3 times 5 to the power of 2 times 7 to the power of 1. For part A of question 2, we need to describe the transformation from A to B. Note that the orientation of the shape does not change, neither the size of the shape. So this is a translation by 3 units to the right and then 5 units down. You can check this with any vertex of this shape. So let's write this down. Note that I've written translation by vector 3 minus 5. You can write translation 3 units to the right, 5 down. You would still get the 2 marks. Now for part B, we need to rotate shape A 180 degrees about minus 1, 0. So the point minus 1, 0 is here. Now, if I want to go from the center to this vertex, for example, then I'll have to go 3 units to the right, 1 unit up. And if I rotate this red right angle shape, it's going to be 3 units to the left, 1 unit down. So this vertex here will be here, and the overall shape will look like this. So let's just draw this. If you're not sure how the final shape will look like, you can repeat this process with more vertices. For example, you can take this and rotate 180 degrees to find a second point. Once you find 2 or 3 points, then it's easy to connect them and get the final shape. Or you can even use tracing paper and rotate the shape to find the exact location. For question 3, I'm given 4 numbers and 2 pieces of information. Now, each of those will create one equation, which I'll have to solve. So regarding the median, the 2 middle numbers, if added together and then I divide by 2, will give me 12.5. And then for the range, the largest, which is 15, minus the smallest, which is x, will give me the range, which is 4. Now solving the red equation will give me x is equal to 11. And then if I use that in the blue equation, I'll get 11 plus y over 2 is equal to 12.5. Solving this one will give me y is equal to 14. And those 2 are the 2 final answers. For question 4, I'll start by listing the elements of A and B. So A contains the elements 1, 2, 3, and 6. B has the elements 2, 3, 5, and 7. So A union B are all these elements together without repeating the 2 and the 3, which is in both sets. So 1, 2, 3, 5, 6, 7. And for II, A dash are all the elements that are in the universal set, but not in A. And these are the elements 4, 5, 7, 8, 9, and 10. In part B, we need to explain why A intersection B is not equal to the empty set. And as I said before, this is because 2 and 3 belong to both sets, so it's not empty. Then in part C, we have another set C with 4 elements, such that A intersection C has 2 members, B intersection C has 2 members. Let's draw a Venn diagram. Now, A intersection C is this region here, and B intersection C is this region here. Let's paint them for now blue and red. And we're being told that each of those regions has 2 members, but those 2 regions have no members in common, which means that middle region must be empty. and there should be 2 elements on the left and 2 elements on the right. Now recall from above that A union B is equal to 1, 2, 3, 5, 6, and 7. And in part B above, we explained that A intersection B is not empty because 2 and 3 belong to both sets. So 2 and 3 are here. Therefore, 5, 6, 7, and 1 must be in the union. And if you see, I'll have 2, 4, and 6 element here. So these 4 crosses must be 1, 5, 6, and 7. For question 5, let's start from the fact that the area of the square is 81 cm squared, which means the side of the square must be 9 centimeters. Hence, the radius of the circle is equal to 4.5 centimeters. Now, the total wire needed are the perimeter of the square plus the circumference of the circle. So for the square, 4 times the length plus for the circle 2 pi r. So 36 plus 2 pi times 4.5, which is 36 plus 9 pi. If you put that on the calculator, you'll get an answer of 64.3 centimeters to 3 significant figures. For part A of question 6, I'll start by multiplying everything by 3. So 2f is equal to 12f minus 51. I'll take the 51 to the left so it becomes positive, and then on the right I'll have 12f minus 2f, which is 10f. Therefore, f is 51 over 10. You can write this as a fraction, or if you want, you can convert it as a decimal, which is 5.1. For part B, anything to the power of 0 is equal to 1. For part C, I'll start cancelling out the numbers. 12 over 4 gives me a 3. And then for the letters, when you simplify, you simply subtract the powers. For A, I've got A to the 4 divided by A to the 1. So 4 minus 1 gives me A to the power of 3. Similarly for H, 6 minus 2 is 4, so H to the power of 4. Finally for D, common factor is 4x to the 3y, and then I'm left with 5x squared from the first term plus 3y cubed from the second term. For question 7, I'll work with the left-hand side. 3 to the minus 2 times 3 to the 5. You just add the powers. Minus 2 plus 5 gives me 3. So 3 to the power of 3 over 3 to the 10. The right-hand side remains the same. Again, on the left-hand side, now I have to subtract the powers. So 3 minus 10 is minus 7. So 3 to the minus 7 is equal to 3 to the n. So n must be equal to minus 7. The formula I use for this type of questions is the following. Final amount equals to the initial amount times the multiplying factor. And in this question, I have a reduction by 17%. So my multiplying factor will be 100 minus 17 over 100, which gives me 83 over 100. If you want this as a decimal, at 0.83. So 6,225 is equal to the initial amount times 0.83, which is my multiplying factor. So the initial amount x is equal to 6,225 over 0.83. Put that on the calculator and you'll get an answer of 7,500. For part A of question 9, this number as an ordinary number is 604 with 3 extra zeros. Part B, that's 7 times 10 to the minus 5, because I have 5 zeros before the 7. For part C, you can just plug this into your calculator and get an answer of 200,000, which is equal to 2 times 10 to the power of 5 in standard form. Now, if you want to do this manually, you'll have to start from the denominator and convert both powers of 10 to the same power. So I'll keep the first the same, 4 times 10 to the 5, and then I'm going to convert the other one into 0.2 times 10 to the 5. So this will give me 3.8 times 10 to the power of 5. So now I have 7.6 times 10 to the power of 10 over 3.8 times 10 to the power of 5. And if you split this into two parts, so the 7.6 over 3.8 will give me an answer of 2, and then the other 2, just subtract the power, so that's 10 to the power of 5, which is the same answer as the one the calculator gives. For question 10, to find the area of this shape, I'll find the area of the trapezium and the area of the rectangle and add them up. For the rectangle, I have the dimensions. Those are 23 and 4.7 centimeters. Now, I don't have the height of the trapezium, and in order to find it, I'll use the following right angle triangle. So let's extract this triangle at the bottom and find the height, which I denoted as x. So using right angle trigonometry, I have sine of 30 is equal to opposite over hypotenuse. So x is equal to 5 sine of 30. Let the calculator do the work. This will give you 2.5 centimeters. As I said before, the total area is equal to the area of the trapezium plus the area of the rectangle. And the area of the trapezium is given by the following formula. So for the trapezium, I have 1 over 2 times 23 plus 11 times 2.5, which is the height I just found above, plus the area of the rectangle, which is 23 times 4.7. The area of the trapezium is 42.5. The area of the rectangle is 108.1. So the total area is 150.6 cm squared. For question 11, I have to draw a cumulative frequency graph. Now, the upper bounds of the time would be the x coordinates, and the cumulative frequencies will be the y coordinates. Notice that all the times start from 0, so I'll connect my graph to the origin. And now that you have plotted the points, you can join them using a smooth curve or using line segments and your ruler. I always prefer the line segments and the ruler. In part B, I need to find the interquartile range. This is equal to Q3 minus Q1. So I'll find Q1 and Q3 first. Q1 and Q3 are found by taking either a quarter of 60 or 3/4 of 60. So it's the 15th observation or the 45th observation, and this will be found from my graph. So let's go back to the graph. So I'll need to find the x coordinate for a y coordinate of 15 and a y coordinate of 45. So the two readings on the x axis are 8.5 and 22.5. According to your graph, you might not get exactly the same answers, but something similar. So going back to question B, I have 8.5 for Q1 and 22.5 for Q3. Now the mark scheme accepts answers between 8 and 9.5 for Q1 and 21 to 23 for Q3. So IQR interquartile range is equal to Q3 minus Q1, which is 22.5 minus 8.5, and according to my answers, I get a value of 14. For part C, it says 25 workers spend more than W hours working from home. we need to find an estimate for the value of W. Note that we have a cumulative graph, which means it works in terms of less than something. So if I have 25 workers more than W, it means the rest 35 are less than W. So let's go to the graph, and the target this time will be 35 on the vertical axis in order to find the X value that corresponds to W. And according to my graph, I get a value of about 15.5. Now the mark scheme accepts answers between 16.5 up to 18.5. Finally, for part D, I need to find the probability that the randomly chosen worker is between 5 and 10. So that would be the number of workers between 5 and 10 over the total, which is 60. Now, the information we're given is from 0 up to a point. So to find the number of workers between 5 and 10, we'll find how many are between 0 and 10 and subtract the ones that were between 0 and 5. Now, no need to work with the graph because 5 and 10 appear on the table. So there are 17 workers between 0 and 10. There are 6 between 0 and 5. So 17 minus 6, that's 11 workers between 5 and 10. So that's the logic behind it. So final answer, 11 over 60, since I'm asked for a probability. For question 12, the most important piece of information I'm given is this one here. CD is 1.5 times BE. So this one is 1.5 times its corresponding parallel line here. So this is the scale factor from the small triangle to the big triangle. So in part A, to find in D, I'll work with the right sides of the two triangles, which are AE, and that's given, and A in D, which is this one. And once I find those, I'll just subtract them to find ED. So A in D, which is part of the large triangle, is 1.5 times AE, which is 1.5 times 10, which will give me 15. So in D is equal to 15 minus 10, and this will give me 5 centimeters. Now for part B, I'm given the length of A and B in terms of X and BC in terms of X as well. So let's go back to the shape and enter this information. So again, I will work with the scale factor. AC, which is this one, is equal to A and B times 1.5. Now AC, which is the long one, is equal to the sum of those two. So let's find this. So AC is equal to 2x plus 5 plus 3x minus 5, which gives me 5x. So AC is equal to 1.5 times A and B. 5x is equal to 1.5 times 2x plus 5. Let's expand. 5x is equal to 3x plus 7.5. So 2x is equal to 7.5. Divide this by 2. X is 3.75. In question 13, we're asked to write down a formula for the perimeter in terms of R. Now the perimeter is equal to AO, which is a radius, OB, which is another radius, and AB, which is an arc. The formula for the arc length is the following. So let's find the full formula. P is equal to 60 over 360 times 2 pi r plus r plus r. Let's simplify this. This is 1 over 6 times 2 will give me 2 over 6 or 1 over 3 pi r plus 2r. Now the question asks to put it in this form where r is a common factor. So r bracket 1 over 3 pi plus 2 is my final form. Note though, writing this as your final answer will not give you full marks. You need to put the p equals at the beginning because the question asks for a formula, not an expression. For question 14, I'll draw a tree diagram. For the coin, I only have heads and tails with probability 0.8 and probability for a tail 0.2. Now for the coin, I'm not interested in all the outcomes. I'm only interested whether it's a 6 or not a 6. And the probability of getting a 6 is not 1 over 6 because it's biased. Let's call this probability P. Therefore, the probability of not getting a 6 is 1 minus P. Now, I'm given that the probability of a 6 and a head is 0.24, and this corresponds to the 0.8 times P. So let's create an equation. 0.8 times P is equal to 0.24. So P is equal to 0.24 over 0.8, which gives me 0.3. Now I'm being asked to find the probability of getting a tails and a 6, which is this combination here. And this will be equal to 0.2 times P. So 0.2 times 0.3, which will give me 0.06. And that's my final answer. For question 15, A and B, B, C, and C, D are the three sides of a regular pentagon. So the pentagon would look like this. So angle BCD is an interior angle of the pentagon and DCE is an exterior. And to find the exterior angle, the blue one, I'll use the following formula. N is 5 because I have a pentagon. So this is 360 over 5, which is equal to 72 degrees. So now I can use the formula for the area of a triangle, which is the following. So let's plug in the values. This is 1 over 2 times 6.5 times 3 times sine of 72. Put this on the calculator and you'll get a value of 9.27 centimeters squared, correct to 3 significant figures. For question 16, you should recognize each of those graphs. Now the first one is y is equal to sine x. B is a positive quadratic, so it's y equals x squared minus something because the y-intercept is negative. The C1 is y equals minus x squared. Part D is y equals cos x. E is a reciprocal, negative reciprocal, y equals minus 1 over x or any other numerator as long as it's negative. And then F is y equals x cubed, that's a cubic one. So if you go and answer the questions, for I, this is graph E, and for II, it's graph A. For question 17, I'll start by finding fg of x. So fg of x is like an invisible pair of brackets here. This is equal to f of g, which is 3x plus 1. And this is equal to, and I'm going to go to my function f, and I'm going to replace all the x's with 3x plus 1. So I get 3x plus 1 over 2 times 3x plus 1 minus 4. So let's simplify this now. This is equal to 3x plus 1 over 6x plus 2 minus 4, which gives me a fraction 3x plus 1 over 6x minus 2. Next, I'm going to consider fg of k. Now, fg of k is the same thing as this one, but instead of x, I have letter k, and this must be equal to 2. So 3k plus 1 over 6k minus 2 is equal to 2. Let's start by cross multiplying. 3k plus 1 is equal to 2 times 6k minus 2. Let's expand the right hand side. 12k minus 4. I'll collect all the k's on the right hand side. So 12k minus 3k. I have 9k on the right. And on the left, it's 1 plus 4, which is 5. So k is equal to 5 over 9. I'm going to leave this as a fraction. 5 over 9 is the final answer. For question 18, let x be equal to 0.306, 306, and so on. So you can notice that 306 is being repeated, and the first repeating pattern is this one. Now, this repeating pattern starts exactly after the decimal and ends 3 places after the decimal. Therefore, I'll have 1000x equals to 306.306 and so on. And x is equal to 0.306 and so on. And if I subtract those two, I will get 999x equals to 306 without any decimals. So x is equal to 306 over 999. And you can simplify this to 34 over 111 as required. For question 19, I'll start with finding the lower and upper bounds for speed and time. Speed is equal to 19, correct to the nearest whole number, so lower bound is 18.5, upper bound is 19.5. Time is 1.5 hours to 1 decimal place, so 1.45 is the lower bound, 1.55 is the upper bound. Now distance is equal to speed times time. I need the upper bound for distance, so I'll have upper bound of speed times the upper bound for time. Let's substitute the values from above. 19.5 times 1.55. This will give me 30.225. I need the answer correct to 3 significant figures. So this is 30.2 kilometers. For question 20, I'll solve this inequality as if it was an equation. I'll proceed with factorization, but you can use the quadratic formula if you want. I get 3x plus 4 times 2x minus 5 is greater than 0. Forget the greater than 0 for a moment. Let's find what we call the critical values. X equals to minus 4 over 3. Or x equals to 5 over 2. The inequality sign is irrelevant for this step, but is important for the next step. Let's draw a number line with our positive quadratic here. So this quadratic cuts the x-axis at 2 points. I want this quadratic to be above the x-axis. And the values of x that satisfy these are the values of x to the left of minus 4 over 3 and the values of x to the right of 5 over 2. So my final answers are x less than minus 4 over 3 or x greater than 5 over 2. For question 21, I'll start with a rough sketch. I made sure that b is to the right of a and b is above a based on the coordinates of these 2 points. And I'll start by finding the gradient of a and b using the following formula. And then, because the sides of a square are perpendicular, I'll find the gradient of BC using the following rule. And then using this reversed gradient and the 0.35, I'll find the equation of BC. So let's start. Gradient of A and B is equal to 5 minus 2 over 3 minus 5, and this will give me 3 over 8. Therefore, the gradient of BC is equal to minus 8 over 3. So let's find the equation of line BC. Y is equal minus 8 over 3x plus c. I will use the 0.35 which lies on this line. 5 is equal to minus 8 over 3 times 3 plus c. So 5 is equal to minus 8 plus c. C comes out to be 13. So the equation of line BC is equal to y equals minus 8 over 3x plus 13. I need this in a different form. I need everything on one side and I need all the coefficients to be integers. So I'll start by multiplying everything by 3. So 3y is equal to minus 8x plus 39. And if I take everything to the left hand side, I will get 8x plus 3y minus 39 is equal to 0. Note that there is no restriction to which side to take the terms, so another possible equation would be minus 8x minus 3y plus 39 is equal to 0. For question 22, I'll solve the simultaneous equations using substitution. I will replace these two y's with 3x minus 1. So x squared plus 3x minus 1 squared is equal to 3x minus 1 plus 11. Let's expand the brackets. So x squared plus 9x squared minus 6x plus 1 is equal to 3x plus 10. Let's take everything to the left. 10x squared minus 9x minus 9 is equal to 0. And now I have to solve this quadratic equation. I will solve it using factorization, but if you want, you can use the quadratic formula. So 5x plus 3 times 2x minus 3 is equal to 0. So x is minus 3 over 5, or x is equal to 3 over 2. Now let's use the linear equation, the second one, to find the values of y. So y is equal to 3 times minus 3 over 5 minus 1. Y comes out to be minus 14 over 5. And from the second x value, y is equal to 3 times 3 over 2 minus 1. Y is equal to 7 over 2. So let's pair our solutions. X equals to minus 3 over 5 with y is equal to minus 14 over 5. And x equals to 3 over 2 with y is equal to 7 over 2. For question 23, we have this point and we need to apply two transformations. Now for the first one, recognize it as a translation by 10 units up. So the image will be 6, 7. And the second one is a stretch along the x-axis by a scale factor of 1 over 3. So this will be mapped onto 2 minus 3. For question 24, I have the following information. I have a hemisphere with a radius of x. The total height of this shape is 4 times x, which means that the height of the cone is equal to 3x. Now I will work out the volume of S using the following formulae. So volume of S is equal to half a sphere, so a half of 4 over 3 pi x cubed, plus the volume of the cone is a third, pi r squared h. Now the radius is x, and the height is 3x. So if I simplify this, I will get 2 over 3 pi x cubed plus pi x cubed, which simplifies further to 5 over 3 pi x cubed. Now find the volume of the other sphere, and this is 4 over 3 pi r squared, and we're being told that the radius is k times x, so kx to the power of 3. And if I expand this, I'll get 4 over 3 pi k to the 3 x to the 3. Then I'm going to use the fact that the volume of this sphere is 12.5 times the volume of S. So 4 over 3 pi k to the power of 3 x to the power of 3 is equal to 12.5 times 5 over 3 pi x to the power of 3. I can cancel out the pi on each side and the x to the power of 3 on each side. So I'll be left with 4 over 3 k to the power of 3 is equal to, let's do this calculation on the calculator, it will give me 125 over 6. So k to the power of 3 is 125 over 6 divided by 4 over 3, which simplifies to 125 over 8. So k is the cube root of this fraction, and this comes out to be 5 over 2. Now for part B, I have two similar shapes, and the volume of T is 512 times the volume of S. I will work with the standard table I use in similar areas and volumes. I usually let K be the scale factor of height. So the scale factor for the area is K squared, and the scale factor for the volume is K to the power of 3. Note that K has nothing to do with the K I found in part A. This is a different K that denotes the scale factor of the height between solid T and solid S. Now, I'm being told that the scale factor for the area is D, so this K squared is equal to D, but I'm given that the scale factor for the volume is 512, so K to the power of 3 is 512, so K is the cube root of 512, which is 8, so K squared is equal to 8 squared, which is 64, and this is the value of D. For question 25, I'm given that OP is equal to 2A and OR is equal to 3B. I'm also given that M lies on PQ such that PM is a quarter of PQ. Therefore, vector PM is equal to a quarter of PQ, which is equal to 3B, because this is a parallelogram, and this is 3/4 of B. Similarly, from the statement below, vector Rn is equal to 4 over 5 times the vector Rq, and the vector Rq is equal to 2A, again because I have a parallelogram, so this is equal to 8 over 5A. In part I of A, I need to find ON. Now ON is equal to OR followed by Rn. OR is equal to 3B. Rn, I just found it above, is 8 over 5A. So answer 8 over 5A plus 3B. Doesn't matter if you put them in alphabetical order or not. Now to find MR below, I'll need to follow the route MP plus PO plus OR. Now MP is the reverse of PM, which I found to be 3 over 4B. So I have minus 3 over 4B plus PO, which is the reverse of OP. So let's change the plus into a minus 2a plus OR, which is equal to 3b. Now if I simplify this, I'll get minus 2a plus 9 over 4b. For the last part, I'm given that OY is equal to k times ON, where k is a fraction. So if I go to my shape, OY is this one, that's k times ON. So let's put a k there. Note that if this is k times the whole thing, then the remaining is 1 minus k. Now similarly, my is a fraction of mr. Let's call this fraction x. So yr is the remaining fraction, so it's 1 minus x. You can use any letter for this one, doesn't make a difference. So if I go down here, OY is equal to k times ON, which is equal to k times 8 over 5a plus 3b. I found this before, and if I expand, I'll get 8 over 5ka plus 3kb. Now, I will find an alternative way to go from O to Y, and I will choose the following: OP PM plus MY. You can use any method. You can choose the roots OR, R, Y, but I'll just do this one. Doesn't make a difference which one you choose. So OY is equal to OP plus PM plus MY. Now OP is equal to 2A plus PM, which we already found to be 3 over 4B, plus MY. Now MY is a fraction of MR, and this fraction we called it X. So it's X times MR. Now we found MR in part A. This is minus 2A plus 9 over 4B. So let's expand. I've got 2A plus 3 over 4B minus 2XA plus 9 over 4XB. And now I'm going to collect all the A's together and all the B's together. So I have 2A minus 2XA plus 3 over 4B plus 9 over 4XB. And I'm going to factorize the A and the B from the first two and the last two. So this gives me A 2 minus 2x plus B 3 over 4 plus 9 over 4x. So what I've managed now is to have two expressions for OY, and because OY is essentially the same thing, has the same starting and same end point, then the coefficients of A and B must be equal. So the first equation I'm going to have is 2 minus 2x must be equal to 8 over 5k, and the second equation will involve the coefficients of B. So 3k is equal to this expression here. So let's write those down. 2 minus 2x is equal to 8 over 5k, and the second one is 3 over 4 plus 9 over 4x is equal to 3k. And I'm going to solve this simultaneously. I'll make x the subject in the blue one. So 2 minus 8 over 5k is equal to 2x. And if I divide everything by 2, I'll get 1 minus 4 over 5k is equal to x. And I'm going to replace this into the red equation. This will give me 3 over 4 plus 9 over 4 times 1 minus 4 over 5k is equal to 3x. Let's expand. 3 over 4 plus 9 over 4 minus 9 over 5k is equal to 3k. Let's take all the k's to the right and keep the constants on the left and simplify. So 3 is equal to 24 over 5k, which means that k is equal to 5 over 8, and this is my final answer. I'll start question 26 with the expression in the square brackets, and I will simplify this. I have 3x minus 5 divided by, and then I'll factorize this. I get 3x minus 5 times x plus 2, and then the denominator stays the same. Now this is equal to 3x minus 5. I'm going to change the division to multiplication, and I'm going to flip my fraction. So I have 4x minus 1 in the numerator over 3x minus 5 times x plus 2 in the denominator, and I can cancel out the 3x minus 5, so I'm left with 4x minus 1 over x plus 2. So let's merge everything together now. So 4 minus 4x minus 1 over x plus 2. I'll make this into a single fraction. So 4 times x plus 2 minus bracket 4x minus 1 over x plus 2. Note the use of bracket here because I have a minus outside the fraction. I need to put that bracket. Let's expand the brackets on the numerator. 4x plus 8 minus 4x plus 1 over x plus 2. And if I simplify, I will get 9 over x plus 2. And this is my final answer.